Dear children, in the previous lesson we have studied ionization enthalpy, electron gain enthalpy, atomic radii and electronegativity along a period and along a group. These were the properties of an individual atom. But today in the chapter States of Matter, we will study about the properties which we observe normally. For example, water wets. The single particle of the water, that is single molecule of the water, does not wet. The bulk of the water wets. In the same way, the molecule of a liquid does not boil. The bulk boils. What does this word bulk means? Bulk means the collection of the atoms or the molecules. Today, we will study about such properties in the chapter States of Matter. We know that a matter exists in three states: solid, liquid and gas. You have seen water, it exists in the form of the ice, liquid water and the steam. These three phases of the water or the three states of the matter depends upon the thermal energy and the intermolecular forces. Let me tell you what are these intermolecular forces and thermal energy. Intermolecular forces are the forces of attraction between the individual atoms or the molecules. Let me define intermolecular forces. Intermolecular forces are the forces of attraction and repulsion between interacting particles, atoms and molecules. This term does not include the electrostatic forces that exist between the two oppositely charged ions and the forces that hold atoms of a molecule together, that is, covalent bond. These intermolecular forces are not including the covalent bonds. The strength of the intermolecular forces vary. There are different types of intermolecular forces. Attractive intermolecular forces are known as van der Waals forces in honor of Dutch scientist Johannes van der Waals, who explained the deviation of the real gases from the ideal behavior through these forces. The van der Waals forces are of different types: dispersion forces, also known as London forces, dipole-induced dipole forces and dipole-dipole forces. First of all, I'll take dispersion forces. Dispersion forces proposed by the German physicist Fritz London, forces of attraction between the two temporary dipoles, is known as the dispersion forces. These forces are always attractive and interaction energy is inversely proportional to the sixth power of the distance between two interacting particles. Their magnitude depend on the polarizability of the particles. London forces or the dispersion forces, how they are originated, let me explain you. There are atoms or the non-polar molecules in which the electronic charge is symmetrically distributed. They are non-polar. Now what happens when the electrons are moving in the shells? All of a sudden, for a moment, just for a fraction of a second, all these electrons, they come on one side in an atom. This is just an accidental case. And when the electrons, they collect at one center, at one corner, a negative charge and a positive charge develops in that atom. And it induces dipole in the neighboring atom. This is very temporary, but it is attractive type. And it induces temporary dipole throughout the chain, and such forces are known as London forces. You can see this in the picture. Helium atom 1 and helium atom 2. The electrons are uniformly distributed in figure A. But what happens Accidentally, in helium atom 1, all the electrons, they gather at one point and it gets the partial negative and the other end gets the partial positive charge. It is shown by delta negative and delta positive. This induces the temporary dipole in the neighboring helium atom, and then the partial positive charge and the partial negative charge, they attract each other and it holds the molecules together. This is London forces. The next is dipole-dipole forces. Now let me tell you how it develops. The element or the atom which has lower electronegativity develops partial positive charge, and the other element which has higher electronegativity develops permanently negative charge. This permanent dipole is throughout in the bulk. Let us define dipole-dipole forces. Dipole-dipole forces act between the molecules possessing permanent dipole. Ends of the dipoles possess partial charge, and these charges are shown by Greek delta, that is letter delta. The attractive force decreases with the increase of the distance between the dipole. In the picture, you can see the partial positive and the partial negative charges and how these positive and negative charges are holding the different molecules. This is dipole-dipole forces. The next type of intermolecular forces are dipole-induced dipole forces. Such type of forces exist between a molecule having a permanent dipole and the other molecule which is non-polar. The molecule which has dipole, it induces dipole in the non-polar molecule, and hence in the neighboring molecule also the positive and the negative charge develops and it holds the molecule together. This type of attractive forces operate between the polar molecules having permanent dipole and the molecules lacking permanent dipole. Permanent dipole of the polar molecules induces dipole on the electrically neutral molecules by deforming its electronic cloud. Induced dipole moment depends upon the dipole moment present in the permanent dipole and the polarizability of the electrically neutral molecules. Now you can see the picture. The one molecule is hydrogen chloride which has permanent dipole, and the other one is a hydrogen molecule which is non-polar. Now hydrogen chloride has a permanent dipole. Hydrogen is having a partial positive and the chloride ion has the partial negative charge. Whereas in the hydrogen molecule there is no charge. But this permanent dipole in hydrogen chloride will induce dipole in the neighboring hydrogen molecule, and the permanent dipole of the neighboring molecule induces the dipole in the neighboring molecule and it will hold the molecules together. It is again a very weak type of attractive force. The another aspect which decides that a molecule will exist in solid, liquid or gaseous state is thermal energy. Thermal energy is the energy due to the motion of the atoms and the molecules. Let me define. Thermal energy is the energy of a body arising from the motion of its atoms or the molecules. It is directly proportional to the temperature of the substance. It is the measure of average kinetic energy of the particles of the matter and is thus responsible for the movement of the particles. This movement of particles is called thermal motion. Intermolecular forces versus thermal energy. The intermolecular forces are strongest in solid state. Then in the liquid state it is of intermediate type, and in the gases these intermolecular forces are weakest. but thermal energy is highest in the case of the gases. The gaseous atoms or the molecules are freely moving and they are in constant motion. Thermal energy is of intermediate type in the liquid state and it is minimum in the case of the solids. We have studied in the previous classes that in the case of the solids, the particles are not free to move. You can see the graphical representation, the gas, liquid and the solids. Here you can see the predominance of the intermolecular interaction which is highest in the solid, intermediate in the liquid and very less in the gaseous state. The predominance of the thermal energy is highest in the gases, lesser in the liquid and least in the solid. Just now we have studied that there are three states of matter and these three states depend upon the strength of the intermolecular forces and thermal energy. These are the two deciding factors that which state will prevail. If there is a balance between the intermolecular forces and thermal energy, there will be a liquid state. And if the intermolecular forces are very strong as compared to the thermal energy, it will be a solid state. We can convert a gaseous state into liquid state by decreasing the thermal energy. Dear children, just now I have explained you the three states of matter and the three states depend upon the strength of the intermolecular forces and the thermal energy. If the intermolecular forces are very strong and the thermal energy is very low, it will be a solid state. And if the intermolecular forces are very weak and the thermal energy is very high, then it will be a gaseous state. We can convert a gas into a liquid state by lowering the thermal energy. I hope all these concepts and the three states of matter are clear to you.